of a remix kind of sequencing of today, but so we loaded, let's say, various visualizations from different projects, and some of them, you have already seen yesterday on a small screen, but just wanted to, kind of bring them up and their native size, and then so we'll just kind of show you a few things from different projects, so we can look at the details, and then I think maybe Jeremy wants to load the big engine data set.
Yeah, sure.
And then Tisa is also going to talk about stuff. So, you want to say what this?
Sure. Well, this is so this image that we're looking at right here is actually is a timeline of a single level from the game Res, which was is a sort of a music shooter with that had some really interesting and unusual aesthetics. It was famous for the fact that it had an optional shipping vibration control to give pulse-based feedback while you were playing. And here, what we have essentially is two streams. The top stream is showing a keyframe every 5 seconds, and the bottom is showing a keyframe every second. So you have two parallel streams that are narrating the same video at different densities. And then the bottom three graphs are, one of which is based on feature extraction. For example, feature extraction from these little bars that we just wrote something very simple to just read the pixels on the screen itself, because we didn't have access to the software. And then those values, as they change, are being recognized. Here's a power-up event when the player reaches the next level. Here's a staging event, and those are just being represented in these colored boxes as a way of kind of summarizing what's happening in the
So the imagery, in addition to measuring properties of a whole image, you can basically draw rectangles of shapes around a particular part of the image, and then measure very image parameters. So the way you would imaging, you would basically draw a rectangle around the bar, and then just measure the brightness of the bar with time, and then you interpret this. So it's like reverse engineering the values, right, which the bar represents.
And in this, video games and simulations are a particularly interesting genre because they often tend to have informatic displays, HUDs, or signs or symbols, like collision just happened and a bright red ring, will appear, something like that, that are meant to be, symbolically unambiguous enough that the player can read the game, unlike the world. And because those things are often legible, it means that in terms of like say computer vision applications, that a lot of games are basically a toy problem. It's trivial to read many of the symbols because they're unambiguous. They always appear in exactly the same place, and they're always this shade of red. And then we can just scrape them all out, summarize them, and we have a transcript of what appears to be a quite complex space, but in some ways highly structured. So, and what did you want next? Oh, sure. So, if you haven't seen this image, have you seen this image before?
No.
Okay. This is 1 hour from an 80-hour recording that I mentioned earlier, taken from Star Wars: Knights of the Old Republic. And here, keyframes that have been extracted from the video stream are attached to the timeline at the moment where the mode changes. Now, by mode, we mean here these things: a cinematic, combat, a menu, another type of menu, 3D motion, and these letterbox films that show in camera. One of the things that is, this graph is really just showing the internal behavior of our system that's turning this hour of video into something we can read. And if you look at the color distribution across this line, the story that we get is a story with a lot of black bars and a lot of green and a little bit of red. What's probably surprising about this story, as soon as you understand what it's mapping, is that in this 1 hour, we've spent an enormous amount of our time either watching pre-recorded films or in menus and loading screens. That is to say that this highly immersive 3D interactive video game is actually 40 minutes of movies and menus and 20 minutes of running around in a virtual world. If you look at all 80 hours, exactly the same thing. You know, 60 hours of movies and menus and 20 hours of running around in the 3D world. So the way in which things like this enable you to ask, what is interactivity and what is interactive media for display becomes interesting from this perspective.
And actually, maybe from here.